Hey everyone, we are going to work on graphing inequalities, linear inequalities. First of all, linear inequalities are truly not very different than linear inequalities. The only thing we have as a difference is how you graph them. So we know with inequalities we need to pay attention to positive and negative multiplication and or negative multiplication and division, but beyond that, like, we're looking at the exact same thing. So we're going to take these notes. These notes are long-ish, and I can only show you part of them at a time, but we're going to take these notes and we are going to make sure these notes are set up and ready to go in your notebook. You have this exact sheet in your packet, so please, if you need, pause this video and take them out right now so that way you can start doing this. So to start out with, we are going to rearrange the equation into slope-intercept form. I've said from the beginning that slope-intercept form has so many pros to it, it's ridiculous. Slope-intercept form is really, really helpful for graphing equations in particular, and considering we're graphing inequalities now, slope-intercept form is going to pay off in dividends. So we're going to start out first by turning this into slope-intercept form, meaning our inequality is going to be in this format, y equals mx plus b. Now there's obviously going to be an inequality here. In this case, it's going to be a less than or a greater than sign, but it's going to have this same format of y on one side and then mx plus b, slope x plus the y-intercept on the other side. So let's start out and do that. I'm going to subtract 2x on both sides. And notice, because I have that vertical line there, I don't really need to pay attention to the inequality so much. I'm going to keep it up to date and everything as I complete these notes, but in all reality, like, I don't need to pay attention to it unless I multiply or divide by a negative number. And that's what I'm about to do. I'm going to divide by a -3 on all of the terms. And when I do that, need to make sure, and this was a common error in most people's module 2 test. Please make sure you flip your inequality when you divide by a negative number. If you don't, you have the wrong inequality and you will graph the wrong inequality, and that will be such a bummer for you, because this is the only nuance that you have to pay attention to when it comes to inequalities. So -2 divided by a -3 gets us a positive 2/3 for our slope times x. 12 divided by a -3 gets us a -4. So there is my inequality that I'm going to graph. Now, I am going to take this inequality and I'm going to write down its slope and its y-intercept. The slope is 2/3. The y-intercept is 0, -4. And now I am going to hide that inequality, mainly because I need to be able to see the rest of this set of notes. So the rest of these set of notes, let's move this over so we can see it all as much as we can. The rest of this set of notes are these. So we have our slope and our y-intercept. So we can plot these. Our y-intercept is 0, -4, 1, 2, 3, 4. Our slope is 2/3, up 2 over 3, up 2 over 3. I could go down 2 over 3. But what I am not going to do is I'm not going to connect the dots. Why? Because the inequality is what I have to now pay attention to. I have to deal with this greater than sign that we have here. The way I deal with that is by determining if I'm going to have a solid line or a broken line and what direction I'm going to end up shading. So when we deal with inequalities, we are paying attention to a whole huge range of coordinates that could be solutions to this. It's not just one solution or a line, but it's instead a huge, vast region of solutions. So just like when we were doing our inequalities on number lines, we had a open circle or a closed circle. In this case, we have a solid line or a broken line. A solid line, I want to see inequalities that look like this: less than or equal to, or greater than or equal to Broken lines will end up being less than or greater than signs. In this case, our graph is a graph of y is greater than 2/3 plus 2/3 x minus 4. So we have a dashed line or a broken line. So I am going to now draw a broken line. Notice it's a dashed line. Cool? Cool. I'm going to draw my arrows on either end so I know that it continues on forever. And then the other nuance that we need to pay attention to that also comes from that inequality is whether or not we are going to be shading above or below. So if we have a broken line, that means that none of the solutions lie on this line. It's a region below or above that actually show the real solutions for this situation. So to shade above, I want to see greater than or equal to inequalities. To shade below, I'll have less than or equal to inequalities. So again, our equation y, or inequality y, is greater than 2/3 x minus 4. This greater than is what I'm going to focus on. Greater than. So that means greater than, I'm going to shade above. And when I shade above, I'm going to make it just nice and simple and say all of this above this line, and I'm just drawing those lines like opposite of what the slope of this line is. All of this area is valid area for this particular graph. If you want to, you can truly take your pencil and shade all of this. You're welcome to. It's completely not necessary. This sort of shading is actually really common in mathematics, and so you can just shade above just like that. So your final set of notes starts out with our equation or inequality and solving it, showing our actual graph, and then showing these absolute fabulous little hacks that we can use to show if our line is going to be broken and what direction we are going to shade. Okay, thank you for watching. You have 2 more videos for this particular lesson. Actually, maybe 3. I can't remember. Either way, you have a couple more videos before you start the must-do practice problems. Be sure to watch them. Bye.